beautiful robots. Those were shipped off to the RDM harbor in Rotterdam. We needed to create a bit of a niche of autonomy to play with these 2.5-ton monsters. So we managed to get a hold of these robots for basically scrap prices. And one of the first projects that we explored was this vault that, for which we invited Matthias Riebmann, who is working at the Block Research Group at the ETH, who's the author of Rhino Vault, a really fantastic software that allows you to design structures that are compression only. I'll address that more in depth later. And here we really sort of took that approach of hot wire cutting. We brought it to the industrial robots that allowed for much more freedom of movement, allowing us to create elements that are more intrinsic. And at the RDM, we really explored that freedom. At some point, Chris took over in the assembly. It was one of the most pleasurable moments in my work life. I escaped for a couple of days when the project neared its completion, and I was very nervous for the final assembly because all of the troubles and errors aggregate, and assembly is a nightmare. And then I came back and Chris had assembled it, and it was just, thank you, Chris. It was such a cool moment, and you pulled it off like it was nothing, and I was so stressed out. But increasingly, I start to think of architecture in really banal terms. Is in the sense that you have the market value of the built artifact, right? The building or the pavilion or whatever it is. If you subtract the cost of the materials and labor from it, the market value of your building, of your pavilion, subtract the cost and labor from it, and what is left is architecture, right? And I think maybe it's instrumental to think of architecture in these kind of dumb, banal economic terms. Maybe there's something clever about it. So I mentioned before that we utilized this Rhino Vault in this project. Here you see the faces of the elements are normal to the thrust vectors of the building, of the pavilion. So foam, EPS foam, can deal with a lot of compression strength. So the design was optimized such that only compression forces acted upon the structure. Now the problem with the structure was a little bit that while its materialization was, kind of smart and highly cost effective, in terms of materiality, maybe there was something to...
Very delighted to be here today. After I think 1.5 years I was here ago too. I'm going to talk about grammaticular research in general, and specifically our idea of, or concept of how we will try to bring robots directly to construction sites, to autonomously fabricate buildings beyond the usual factory settings. I was already introduced. My name is Kathrin Dörfler. I am a PhD researcher since 3 years already, and I'm part of the NCCR Digital Fabrication, meaning that I'm working in a very interdisciplinary environment. All the projects that I'm showing you are basically works that have been conducted together with roboticists, material scientists, structural engineers. I will start my presentation with the general motivation for on-site fabrication, and then I will give you 2 examples of very exploratory projects, which are not really construction projects. And then I will talk also briefly about our mobile robot, the in situ fabricator. So in the past decades, also from our side, the architectural community, we have been making significant effort to raise the degree of automation in building, construction and architecture. This has been mostly successful in the realms of prefabrication, so off-site automation. where parts of buildings are fabricated in a dedicated environment and then transported to the construction site to be finally assembled. Directly on sites, however, as everybody knows, the level of automation is comparably low, especially when you compare it with automation in other industry sectors. For instance, as everybody knows, automotive industry, we never break the process chain between digital design and the final assembly of components. So the question that we are having is, what if instead of building factories to fabricate building components, we start to see the construction site itself as a factory, where a whole building is fabricated by automated machinery. So the question that we ask us is, what possibilities would open up and which advantage this approach would have compared to automation in prefabrication? And if it's possible that all the steps necessary in the production of a building can be following the same logic, starting from design until to the final assembly. And how can in situ fabrication processes even utilize the fact that we could use local ad hoc available material to lower the cost for transport and energy, and what is necessary also from the robotics point of view to think and eventually realize automated material deposition processes and assembly processes beyond factory setting, meaning that we're working in an unstructured, cluttered environment.
So the first one is this animated work environment. Everyone has these things to the left. Mostly we have worked with multiple screens. What do we do when we want to be co-located, multiple human beings in one space, working on a computer platform, working with digital and manual tools, creating digital analog things? So we said, well, here's the state of the art of these sorts of workplaces. This beautiful one that was exhibited at MoMA doesn't have any real computation. The thing in the middle looks like a bunch of hackers' furniture, right, taken off the streets, a little bit of technology. On the right, basically a prison by Herman Miller to work in. So we thought maybe it could be more like this, something from the past, but a different interpretation of it. So we created this thing. This is about 12, 13, 14 years, inspired very much by things that were going on here. And so we worked in the very early days with software engineers at Rhino and scripted the behaviors of multiple motors and sort of came up with that simulation. You can see how old the project is. This video camera is about the state of the art back when we did this. We might have picked the wrong video camera, but you can see this is a little bit of a longer video. And that's kind of how this thing starts to work a little bit in terms of its behavior. It has all these things. So there's a lot going on. We keep layering in different dimensions of this thing, and it sort of becomes this polyphonic architecture. We have 6 presets, so you can push one of 6 buttons, and you get these sort of configurations. You can fine-tune it with IR sensors. You can move the desks around. They have contact sensors, and by moving them around, we basically have large-scale manipulatives, so that you can configure that wall by way of moving the furniture around. And then there's very low-level intelligence. This is a dumb, intelligent system. It just gets that out of the way for you. And what did we learn with this? We learned that how and where people work. We learned about how to move a continuum surface, which is very complex to characterize. We got some press. It was in a TV show. It's not on the IEEE homepage. It's one of the featured projects for 4 months. It became part of an architectural record.